requesting the ride may all be in completely different time zones. And so once again, I got to learn a lot about how painful time zones can be. So I have a question for everybody. I'm going to ask you some questions as we get started. What time is midnight on a 24-hour clock? 0. I hear 0. Anybody have a different number? Okay. It's a trick question because there are 2 correct answers. It can be 0 to represent midnight at the start of the day, or it can be 24 to represent midnight at the end of the day. And it turns out this is actually fairly important because if you want to compare times but don't want to compare dates, sometimes you need to be able to do that. But not everything supports both of those values, and we're going to get into that in a little bit later. So when time complexity comes into play as well, things like leap seconds, leap days, etc., or if you only have date-time objects for representation, then it becomes even more important that you be able to calculate changes in time within the day without necessarily changing dates. And sometimes we use a 12-hour clock, of course, with AM and PM instead of a 24-hour clock, where the AM means antemeridian, which is morning, and PM means postmeridian, which is the afternoon. Which do you use primarily here? Do you use the 12-hour clock or the 24-hour clock mostly? 24? I mostly use the 12-hour clock in the US, but I use both, obviously, as a programmer. I primarily use the 24-hour clock. So there are a lot of different aspects to representing and calculating time that can come into play. Now, you would like to think that we as developers don't really need to consider all of these things, but it's important to understand the kind of reasons that things have gotten as complicated as they are. We have to calculate time based upon the orbit of the sun. This is solar time. This is what's typically done. But to do that accurately, you have to account for things like the axial tilt and the geometry of our elliptical orbit around the sun. I don't want to do that math on a regular basis, but that is what leads to things like leap seconds and leap years. We can also use atomic time, which is extremely accurate, but is not readily accessible to us. I don't have an atomic clock in my pocket, nor can I have one there at the moment. So while my phone may synchronize with an atomic clock for accuracy, my phone itself is not an atomic clock, for example. So it's useful as a reference point, but it's not really useful for our day-to-day operations. What is important, though, is how definitions have changed over time, how time zones change regularly, for example. International politics play just as big or more important of a role for us as developers in how we deal with time than the orbit of the Earth around the sun, for example. Not every country acknowledges or tracks daylight savings time. The ones that do very rarely change their clocks on the same date, which means that countries are constantly in and out of sync with one another in terms of what time it is. And while basic geometry could draw perfect lines on a map for 24 even time zones, humans are much, much more complex than this. This is our global reality, at least at one point in time. I make no promises for the current accuracy of this map. But you see all the carve-outs. And so while, for example, Copenhagen and Berlin are in their approximate time zone, the same cannot be said for France or Spain. They're completely out of line with what you would expect. And Iceland? Do you see Iceland way out there? What you doing, bud? That's not your time zone. Look at the international date line all the way on the right-hand side. Line? I can draw straighter lines than that when I'm drunk. I mean, come on. But this is what we have to deal with. This is the type of math we have to handle when we want to deal with time zones. And I assure you that nobody in the room knows all of the information conveyed in this map off the top of your head. Nor should you have to. So interestingly enough, because of daylight savings times, we can have multiple time zones in the same time zone. So I am in US Eastern Time, which is represented often as ET. So part of the year, it's EST, and the other part of the year, it's EDT. Right? So that's not confusing at all. And that changes the difference between where I am and the European time zone at different points in time, because it turns out the United States and Denmark don't change clocks for daylight savings time at the same time. So sometimes there's a 6-hour difference, and sometimes there's a 7-hour difference, depending on the exact date that it is. Fortunately, it doesn't happen on this trip, but I have had trips to Europe where daylight savings time happened during that trip. So like you go from being 6 hours from home to 7 hours from home in the middle of the trip, and that's always fun. Even better are all of the different time zones that are off by amounts other than 1 hour. 30 minutes or even 45 minutes. That makes math super tricky. And at this moment, I feel I need to remind you that time is basically a social construct, at least the way we talk about and represent and work with time. And we have lots of different ways about talking about time zones. The first is, of course, the UTC offset, which gives us a very concrete understanding of where in the world the time zone is and how to calculate it. And it's accurate regardless of if DST is in play or not, because you're going to use the correct offset for where you were at that moment in time. I really like this. From a programmatic standpoint, this is my preference because it makes it really easy for me to calculate things. It is not always the most useful when dealing with humans, however, because humans have things like names and abbreviations for time zones, things like EST and EDT. One of the challenges, though, is that we have these things. Eastern Standard Time, EST, is different from like British Summertime, which is also BST. So you have ST and ST, and you think, oh, these are the same concepts. Well, it turns out one of those is actually the wintertime, the other is the summertime. It gets really complicated, but all of these here, -4 GMT, EST, EDT, and America/New York, those all represent Eastern Time in the United States. Although sometimes Eastern Time is -5, not -4, right? And so we have to kind of account for all of this. One of the big benefits we have today is we actually have coordinated time. We have really good time coordination. This has not always been the case. GMT, or Greenwich Mean Time, was established in 1884, and time coordination between countries has been continuously refined since that point in time. Located in Britain, GMT can be confused as British time, but since daylight savings time is observed, this yields BST, which is British Summer Time, which is a different time from GMT. Right? And so this gets super confusing. GMT also used to be referred to as zero time, which became Z time or Z time. And on radios, Z became zebra or zebra. But with the NATO phonetic alphabet, eventually we refined that down to Zulu time. And that is how you'll hear it referred to today. So when you see the Z in your time strings, that refers to Zulu time, which is effectively GMT. UTC, which is what we're most commonly working with, is not actually a time zone. It is a time standard that happens to align with the GMT and Zulu time zones that had previously been in use. And it does utilize atomic time and atomic time standard to define precisely what UTC is for international use. Now, UTC is an international abbreviation that is the same in all languages and is a product of the English Coordinated Universal Time and the, pardon my French, Temps Universel Coordonné. And the astute listener would notice that in neither of these languages would the abbreviation be UTC, despite those three same letters existing in both of those abbreviations, right? You want it to be CUT, and you want it to be this other thing, and so we're just going to rearrange the letters in some other way that makes nobody happy, and that's the new standard. Therefore, UTC was born. And this is important because this is now the way we do everything in terms of our calculations. We have a standard point that we can all calculate from. If we didn't have this, time zone math would be borderline impossible. So if you're really interested in the history of how we got here with dates specifically and calendars, which I'm not going into calendars at all, I'm focusing on time, but if you're really interested in the date history, while I was writing this talk, one of my friends, Ben Dean, gave a really fantastic talk about dates and calendars at C++ Now last year. So feel free to check that out if you're really interested in nerding out about calendars. So, quick quiz. Got a few questions for you. First of all, what time zone is this in? You can't really tell, and I'll zoom in on it for you. You still can't tell. It's just a time. So this is a screenshot from Datadog, and it turns out to know what time zone this is in, you have to dig through your personal settings to figure that out. And it uses this weird combination of your server time and your own personal time choices to make a decision on how to represent times, but it doesn't tell you what it chose. You got to kind of figure that out for your own. This is important because one of the big lessons and takeaways for us as developers and how we handle time zones is to be super transparent with our users what time they're operating in. Why? Well, the servers that I was dealing with in this situation were 3 time zones removed from where I was. So it really mattered if it was in the server time zone or in my time zone, and that radically changed how I was going to troubleshoot a problem when it was occurring. I needed to know that, and that information was not readily available. What time zone is this data in? This is a Google Cloud screenshot. PDT, Pacific Daylight Time. This one is good because it's telling me right off the bat what time zone the data is being presented in. No ambiguity. This is the type of thing that I'm looking for, especially in a logging application when I'm working through times. So let's get into JavaScript for a minute. In what time zone does this code output? Local? We have consensus on local, okay? No. This outputs the Unix epoch in UTC. Not necessarily useful, but that's what it does. What about this one? You take a date, you do toString. What time zone is going to be included in that string output? Local. Yes, you're correct. It is based on the device system time zone. And so it's important because this means you'll get different answers on servers in different regions or on different users' devices. And this is actually one of the challenges. Like, I love Node, and I use Node a lot, but using JavaScript on a server can have challenges with regards to recording timestamps if you use the wrong method to do that. And finally, date.toISOstring. What time zone does this code output? Yeah, UTC, yes. Everybody got the last 2 correct. Good job. So let's take a minute to walk through some real scenarios, things that I have come across in most cases, where time zones may come into play. And I would like to, as we're talking through this, hear about your experiences also. So the first couple examples I'm going to give are using US time zones because it provides some very concrete, challenging examples that I run into all the time. My US team is in Pacific Mountain and Eastern times, so on a daily basis, I'm in 3 different time zones. As opposed to Central European time, which basically covers all of my experience in traveling to Europe. Copenhagen, Berlin, Amsterdam, Paris, Rome, Naples, and even Marrakesh and Agadir are all basically the same time zone, much less challenging on the day-to-day basis in that situation. So this probably seems somewhat ridiculous, but it is amazing to me how many software companies run West Coast servers, regardless of where they are in the United States. And how many pizza chains are headquartered in Denver, Colorado? No idea why. Had to look that one up. But what's even weirder is you can end up with these bizarre situations where somebody may live in one state, and the next state over is actually the closest pizza delivery. And it may only be a couple miles, a few kilometers, super close, but you're actually in different states and you're in different time zones. So this is not really a concocted, this is a very real situation that can occur. So what happens if you're at home, you get on the pizza website, and you use the app or whatever to order the pizza, and that order goes in your time zone. We don't want the order to show up as an hour late as second it shows up at the pizza place just because they happen to be an hour ahead. Nor do we want you sitting at home to order your pizza and you're expecting it to arrive and you don't realize that the store closed an hour earlier because you're an hour off. Those are not scenarios that we would like to have happen. But those are very real scenarios that can happen if we don't account for the time zones correctly between the person placing the order, the person receiving the order, and of course, the place where the order is going to in the first place, which is the server itself. So we have to handle all those situations. And even more interesting, we have to account for the fact that somebody in some pizza headquarters in a completely different time zone is going to want to pull up a report of all the orders that have gone through their system and figure out what's going on. And it needs to show correctly when the order was placed in reference to when it was delivered, regardless of the fact that that's happening in two different time zones. Anybody run into a situation, anything like this before in your code? Yeah? What's your example?
One time we made a system that was running on a boat.
Nice. A system running on a boat, and the boat is moving between time zones. Love it. Custom boat time zone. That's really cool. That's really cool. Definitely never run into that one before. All right, let me talk about my own startup for a minute, because this is one of the first places that I really ran into just how painful this can be. In our very first incarnation, getting off the ground, we had a single serverless provider located in the central time zone, parking lots in the eastern time zone, and a support team in mountain time. And this doesn't sound like a really big deal, but when somebody is trying to check into a parking lot with their app, they're presumably located in the same time zone as that parking lot is. But not always. If somebody travels from a different time zone and comes there and they choose not to update their device to the local time, it means that the time on their phone is actually different from the time on the lot. We have to account for that. Just as importantly, if my support team is 2 hours removed from the parking lot and they're trying to figure out when something happened, then they need to be able to see what happened in the time zone of that lot, not in their own time zone. But by default, JavaScript always operates in either UTC or the local time zone of the device that you're currently on. But in this case, the local time zone of the device the support team is currently on is no relevance whatsoever to where the parking lot is or where the customer was interacting with it. It's not useful to me. So it means that I have to come up with a way to work around the deficiency of JavaScript date times, which is that it's always in my time zone. Starts to make it really, really interesting in that situation. So there's a bunch of different considerations we have to come into. Users may use local versus home time on their device, right? Like right now, I'm in Copenhagen, but I expect to see the correct info when I pull up my support and admin tools back there. We need to be able to answer questions, whether it's for the support team or for users. Is the parking lot currently open? So if there's a period of time that it's open, I need to make sure that I am comparing the user's time within the time range that the lot is open in the same time zone. I've got to make that correction. What is the current price? Because our pricing changes based upon the time of day. And so that's important. as we open more parking lots in different time zones, now we've just added to the complexity. As we add more cloud platform regions, because we're opening more lots, now we have even more time zones on the server side that we have to account for. Same with the support team. We now have a support team in 2 different time zones. And so if we add all 4 major US time zones across all of these activities of support and parking and properties and servers, we now have like 256 possible combinations of interactions between time zones. We have to make all of those things work. It gets complicated fast. Here's a situation I'm sure that we're all familiar with: basic international travel. So in this example, I'm starting from Denver, Colorado, and I'm flying to Berlin, and I have to make 2 layovers along the way. Each of those layovers is itself in a completely different time zone. Why is this important? Because I want my boarding pass to show the local time for my arrival and departures. It's not useful if my boarding pass had a departure time in the time zone I started in instead of in the local time zone when I get there, because now when I arrive, it's really hard to figure out, when am I supposed to be there exactly? Don't make me as the user do the hard work. And this seems trivial, but we have to make those adjustments, because I ordered the flight in one time zone and the destination's in another, and now I've got to be able to do these steps along the way. JavaScript doesn't do this very well. So as we head to the back half of the talk where we actually get into the JavaScript and TypeScript code, I want to pause for a moment to discuss how we store datetime objects in a database. Has everyone heard that the best way to store datetime objects is in UTC? Right? And it makes sense for a lot of things, but I actually don't prefer this approach for all cases anymore. It is not universally the best approach. I'd say it's the best default approach. And so, like for system-generated timestamps, I usually prefer things like UTC, because I really don't care where the server was located. I just need to know in a coordinated way when the event happened. But it can be incredibly important for me to know exactly what the time zone the user was in when they performed an operation. So for user-generated times, a lot of times I prefer to keep the time zone information as part of that date time entry, and then I don't have to look up time zone information in the future when I'm trying to communicate and coordinate with that user. And it doesn't mean that they're always going to be in that time zone, but they were in that time zone at the moment they created that record. So I do generally prefer to keep things with that time zone. And if you have the offset, if you store the offset, you can always calculate UTC from that. It's pretty trivial to do. Every library, even the JavaScript Date object, which is horrible, can handle that much for us. So some timed representation details in JavaScript that we need to know. Epoch is one of the formats. These are the different ways we can represent time. So the first one is epoch. This is the number of milliseconds since the Unix epoch on January 1st, 1970 in UTC. It's always UTC. Unix epoch is always UTC. We can also have a timestamp. So I bring this up because in the language of JavaScript, timestamp refers to the date object itself. In almost all other use cases, we use timestamp to mean something completely different from this, which is why I bring it up. It's the date object in the device locale and time zone. That's the JavaScript definition of a timestamp. ISO, of course, is the ISO formatted string. And we also have RFC 7231 format strings, which, not my favorite thing to say. It can be used a decent bit. And we have, finally, the JavaScript date time strings, which are very much not my favorite, and they can be really hard to parse. They do, fortunately, include the time zone offset and the time zone abbreviation and the day of the week. So it's the most comprehensive, but they're not necessarily always completely, totally standard. And then finally, the locale date time, which you'll probably have noticed is very different from the locale date time here. Because in this case, it's day, month, year instead of, this is day, month, year instead of month, day, year, which is what we see in some places. Anyway, the epoch is interesting. We have date.now. We have date.utc, where you can pass in all these different parameters and still get an epoch back. We can try parsing a string using date.parse. Hint, don't ever use date.parse. Does anybody know why? There's no official standard implementation for date.parse, which means every single JavaScript engine does it slightly differently, which is a problem. So depending on the browser you're using, it can be even the specific build version of something, you're going to get different results for the exact same datetime string. Date.value and getTime is a way to take an existing instance of a date object and get the epoch back out of it. This is my least favorite, I think, of all of them, which is date.setTime. That's right, date objects in JavaScript are mutable, and you can change it to a specific epoch. So that's really not ideal. And finally, you can create a new date object from an epoch. And this is actually something that we probably do a lot. I would say date.now and new date from an epoch are two of the most common JavaScript date things that I see people use. And it's not horrible because they're in UTC. We just have to account for that. What does get interesting, though, is that epoch math, I wouldn't say it doesn't work as expected. It works exactly like you would expect. It just doesn't always produce the results you would expect. So this example, we're getting the epoch out of a date. We're adding 1 millisecond and then creating a new date from that time, and we're trying to compare them. And as you can see, we went back in time. We added a millisecond and rolled back 59 hours, 59 minutes, and 999 milliseconds. Why? Because that was the millisecond that rolled us into daylight savings time. And so nobody is going to intuitively look at these two date time strings and say, there's only 1 millisecond difference between these. You're going to say there's almost an hour between these. But there's not. And so regardless of which direction you're going in, if you're doing the math in the epoch or you're calculating the diff back into epoch, it's not going to make sense to you. And this is exactly why we shouldn't be trusted with time zone math. Fortunately, there are a large number of other ways we can get date information out that should probably definitely help. Date.get full year. Date.set full year. Oh, there we go. They're mutable. Get UTC full year. Set UTC full year. Why does this matter? Because when you are at the end of the year, depending on the exact time it is, it may or may not be this year versus next year. And the same as you saw in December and January, you have some overlap, right? You have several hours of overlap between when the year is this year versus next year. We run into this every day with what date it is, but when you get to the end of the year, we run into that with what year it is. So we've got to be really, really careful about what time zone we're in. Have we accounted for leap year? Have we accounted for leap seconds? Or we could actually get the year wrong. We can get the string. We can create new dates. So these are all different. And with the date, we can pass all kinds of things. We can pass a string. And ironically, new date from a string is much more closely defined than date.parse is on a string. This is actually a preferable method for converting a string to a timestamp than using date.parses, which is super bizarre. We can also pass in numbers. So we can pass in all of the numeric representations of the different positions. So the year, the month, the day, the hour, the minute, the second, the millisecond, all that into the date to create a new date. So you may remember that I mentioned there are 2 correct answers to representing midnight on a given date. This is really, really important with JavaScript because it does time zones so badly and everything's in local time. So at least they could get this right, but they don't. 2400 actually rolls over to the next day. So that means that now the days no longer match, and I can't do the math that I wanted because I'm not actually comparing against 24. I'm now comparing with 0, even though I told it I wanted it to be 24. So now we have to do all kinds of tricky things where I have to detect if it's actually the next day and it's 0 the next day instead of 24 this day. I have to account for that through the logic in my application. I can't just do simple math to determine how many hours have passed this day, for example. And no matter what you do, JavaScript always handles the dates in the local time of the system it's running in, unless you happen to use a method that only works in UTC. So you really can't handle dates in a different region than you're currently located in. That'd be ridiculous. Why would we ever want to handle dates in a different time zone than we're in? Thanks, JavaScript. You're the best. Was anybody here for the game show the other day? I was really disappointed there weren't any time zone questions in there. But this is just kind of showing that example, right? You get into all of this. Why are the numbers not what I expect? So, problems with JavaScript times. No support for time zones other than the user's local and UTC. The parser behavior is so unreliable that it's effectively unusable. We cannot trust it on more than a single device. The date object itself is mutable, so even passing it around within our applications is unsafe. The daylight savings time behavior within the JavaScript date library is unpredictable. It doesn't always get things right because of some of the complexities we talked about earlier. There's confusing use of date for the day of the month and day for the day of the week. That's not necessarily how we think about things. Well, and date is the whole date, not just the day of the month, right? That's in normal language. And then there's no built-in support for calculating the difference between days and times. So I cannot, using JavaScript date objects, compare two dates and get a realistic number back, which is why we have such a big problem with the use of epoch. Because what does every developer do when they need to compare two dates? In JavaScript, they immediately and intuitively convert it to epoch because now I just have numbers and I know how to do math with numbers. I'm good at that, but you always get the wrong number. And what's worse is you'll get the right number for certain sets of values, provided that they are close enough together and don't span a year and don't span a leap year and don't span a leap second and don't span daylight savings time, then it'll work. So it's really easy for us as developers to come up with hundreds and hundreds and hundreds of use cases where our code works perfectly, and then we put it in the wild and it doesn't work at all, and then we've got to figure out why. And the why is because we're really, really bad at time zones. And the JavaScript date library makes it hard for us to do this correctly. So, if you've been around the JavaScript for a while, you've almost definitely heard of Moment.js. So we can definitely count on it to save us here. Except now we can't. It's totally out of date. It's full of issues in modern apps and is no longer being maintained. So here are some of the problems. The objects are still mutable. That can still be a problem in our apps. There's a complete lack of tree shaking, meaning that Moment can be quite heavy in certain applications if you're not using a lot of it. It's a fairly significantly large size, especially if you're utilizing the localization and time zone features within Moment. And finally, there's a lack of support for modern JavaScript improvements. So it's just dated at this point. You should definitely migrate off of Moment.js if you're still using it. Fortunately, we do have something else. But let's talk first about the criteria we should use in choosing a datetime library. First thing is it should have modular architecture. It should support tree shaking. We should only pull in the pieces we actually need to our code and not increase our code weight. It should have support for ECMAScript standards such as INTL for internationalization and new standards that are coming such as Temporal. Really important that we support the standards whenever possible. And finally, it should be focused on support for modern browsers, not just all the legacy browser support. The objects should ideally be immutable so that I can safely pass them around in my application without worry of side effects. And it should have type support, because I don't know about you, I really like working in TypeScript and having very clean types around my data. And when the only data type that you have is date and it doesn't mean a lot, that's not very helpful. This is where Luxon comes into play. Arguably, it's one of the best libraries out there for TypeScript. It checks off all the criteria that I just gave you. And it grew out of the Moment.js project. So it has kind of some built-in maturity in terms of the people that are working on it, really knowing their stuff. So we're going to dig in just a little bit to what Luxon does for you. So it has date time objects, but also duration and interval types. So the date time is what you would expect. It has both date and time components. Duration or interval is a difference between those two. And then durations are human readable things like, 34 minutes. Because humans don't say 34 minutes as 1200 to 1234. And in fact, that's not always relevant because I don't necessarily know off the top of my head when that 34-minute time period starts. I just know that it's 34 minutes. And so Luxon can handle that for us. So we've got the intervals and the durations. It's immutable and chainable and has an unambiguous API. Therefore, there's no confusion about things like day versus date and what they may mean. Parsing and formatting for common and custom formats. In other words, we have reliable string parsing of common string date formats. And it works consistently every single time, the same result. Has native time zone and INTL support, so there's no need to import time zone files or locale files. It's all there right out of the gate. And so these are all the types of things that we need as JavaScript developers to do our time zone work. So here is an example of parsing an ISO string and then testing for expectations. Note that the input time here is +7 time zone. At the time I was testing this, I was in the -4 time zone running the test. And so the Luxon default is to convert everything to the user's local time, which is why we see this adjustment in numbers. So it's basically doing the unit conversion. From 16, you've got to subtract 7 and then subtract another 4, and then we're there. And that's why you see the number change on the hours. And here we're doing the exact same thing, but you'll know that parameter set zone true. That says, hey, I want you to override, I want you to preserve the time zone in my local time zone. So I want the same numbers in my local time zone. So what it's going to do is it's going to preserve the time zone. I'm going to get it. It's going to have the right string, and it's going to give me the correct numbers. I expect that date or that hour to be 9, and it is in fact still 9 because it held onto that time zone information and didn't convert it to my local time zone. You can't do this in JavaScript date time objects. This is of critical importance because it means that I can read a date out of a server or out of a database with time zone information and use it within my client-side JavaScript app with that time zone preserved. This is the secret that allows us to have a report in one time zone or that I'm running on a device in one time zone for data from a different time zone. And so let's say that you have a date time that is on 4 a.m. on August 30th in EDT, but you want a date time that is at 4 a.m. in CET, right here. This is how you do that using Luxon. Keep local time true. And this means that it's going to replace the time zone of the date with the user's local time zone, but keep all the numbers the same. So if it's 4 a.m. in the original date time string and I replace the time zone, it's going to be 4 a.m. in the new time. That means that, for example, if I needed to be able to provide a JavaScript date time object in the user's local time zone and have that work correctly, I can just move things around using this technique to whatever time zone I want while keeping the numbers the same. This is also really important if you have made mistakes or errors with how you represent dates in your database. So one of my clients did something that is not advisable, and that is they took all of the incoming dates from their users, their customers, stripped all the time zone information off of it, and replaced it with Z. The problem is, those weren't actually UTC times. So to get correct dates back out, what we have to do is read the time entry from the database, go find the correct time zone for the user that created the entry based upon their locale information that we have in the database, fortunately, and then rehydrate a time zone corrected value. And this is the technique we use to do that. And so, not something you want to have to do, but Luxon supports it right out of the gate, and it's really easy to work with. This is a technique to grab now for any time zone. So if I want to know what the time is from a time zone on the other side of the world, I can do that. I simply provide the time zone information as that first parameter and say, keep local time false. This is how we can calculate the difference or the interval between two different date time objects. Effectively, we're creating the interval. We're saying date 1 to date 2, and then I can convert it to a duration, and it's going to return something that looks like this: 24 hours, 34 minutes, 49.257 seconds. That is a really great output for us to hand to our users, something that our users can understand, and I didn't have to do any math because Luxon handled figuring out the difference between those two date time objects for me and correctly broke it down in terms of hours, minutes, and seconds without me having to do any work as the developer. That's all the code. That's the output. I dare you to do this using JavaScript dates on your own and get it correct, accounting for all the different situations. So another option that we have available to us is the new Temporal JavaScript spec. Has anybody heard of Temporal? A couple people. Most of you know. Okay. So when I wrote this talk a little bit over a year ago, they promised that Temporal was coming at the end of 2023. It is now August 2024, and now they're promising Temporal will be out by the end of 2024. So we'll see. The good news is that it was first proposed in 2020, so we're 4 years into the process of building out Temporal. We're still waiting on the final version, but it is in stage 3, which means it has been recommended for implementation, and the implementation work has started. So I don't know for sure when it's going to come, but we need to be aware of it because this is going to be built into JavaScript as a replacement to the JavaScript date. Here are some of the improvements from JavaScript. It provides easy-to-use APIs for the date and time computations so that unlike the JavaScript date, which basically does no computational work for us at all, it's going to actually provide that functionality. First-class support for time zones, including DST-safe arithmetic. That's good. Now, Luxon does all these same things for us, but it would be useful to have this built in, right? Dealing only with objects representing fixed dates and times. In other words, well, I'll get into what that means exactly in just a second. Parsing strictly specified string formats. In other words, they fixed all of the ambiguity and inconsistency around how we parse strings, supporting non-Gregorian calendars, which is a very real concern in other parts of the world. It's kind of out of the scope of what we're talking about here, but it's important. And so times without zone, the Temporal API follows a convention of using types whose names start with plain, like plain date, plain time, or plain date time for objects that have no associated time zone. Because I shouldn't always care about a time zone. If all I need somebody to tell me is what time they expect something to happen, I don't always need to anchor that to a specific date and a specific time zone. Sometimes it's enough to say it happens at 1300. And for those situations, we need a way of handling that. In JavaScript, the only way we can handle that is effectively by treating the time as either a number or a string. There's no way to do that with something that actually represents dates and times. There are some key data types, so they've kind of changed the data type structure entirely. Now is actually a type, and it provides methods for getting the current time. An instant is kind of a snapshot. Instant exists in a lot of libraries. I think it exists in Luxon. And it's a fixed point in time that's an exact time, down to the millisecond. Zoned date time is now a time zone aware date and time. It's very specifically indicated that this is time zone aware. And then you have the plain objects, which don't have time zone associated with them. And now we can tell the difference. And then the duration, which is very similar to a Luxon duration, which is giving you like in terms of hours and minutes and seconds. Here's what that actually looks like. This is straight out of the temporal documentation, and it shows the relationship between those data types, but also a little bit just how complex our relationship with time is. Again, remember, time is largely, at least the way we talk about it, it's very much a human construct. We use it to mean things to us in a way that we experience time, more than it is like mathematically meaningful. And so you have this concept of, you have the calendar, they call it the wall clock time. In other words, when you look at a wall clock, you don't care what time zone it is, you just care what time it is for me right here, right now when I'm looking at it. I'm not trying to convey time zone information at that point in time. And then you have all the way on the left the exact time types, and the zoned date time kind of bridges the gap. It contains an exact specific point in time anchored to a time zone in a way that you can get other types of information back out of it again. And so broken down in a different way, this shows how you can represent these different temporal objects in terms of an ISO date string, right? The plain month day is just the month and the day portion. The plain year month is just the year and the month portion. And why is this important? Well, think about, you have a credit card. What is your credit card expiration? Your credit card expiration doesn't give me a time zone, and it usually doesn't even give me a day of the month. It's just a year and a day. And we have a lot of different things like that where that's all we care about. So I don't necessarily need all that extra information. The plain time is just the time portion. I don't always need the date associated with the time. Or I might need the entire instance or the entire zone date time with all the time zone and everything. So if you're interested in getting started with temporal, you can check out the API. There is a polyfill for it. You can check that out on their GitHub page. It has been working for at least a year, year and a half now, and has been available for your use. If you want to get started with it, if you don't want to get started with temporal yet because it's not quite ready, definitely check out Luxon and give that a try for all of your time zone math needs. So in conclusion, remember every application has at least 2 to 3 time zones. Even if you find that you personally as a developer are not having to do time zone math in your application is affected by at least 2 to 3 time zones. Why? The developers, the users, the servers, period. Unless all 3 of those things are in the exact same time zone, that's at least 2. That means that at minimum, when you're looking at server logs or you're looking at data that's coming in from your application, you have to have that consideration, even if it's not in the user-facing part of your application, which it usually actually is. Always consider date and time expectations from the user's perspective. What is the user trying to accomplish? Do they care about the time zone at the time they're doing it? Are they just trying to give you a month and a year as input? Can we figure out everything else from context clues without having to prompt the user for additional information? Awesome, let's do that. Let's make it as easy as possible. But also, let's be super clear with the user when time zones are involved, what time zones are involved, like the earlier examples that I showed with server logs. It's really, really important that I tell the user, here's the time zone you're currently looking at the data in, so that the user can then make reasonable determinations based upon that information. Don't obfuscate the details from the user when they're actually relevant. Never manually calculate time intervals, ever. I know it's tempting to roll back to epoch and do epoch date time math. Don't do it. It's going to be wrong. I promise it's going to be wrong. Carefully select the datetime library that meets your needs. The 2 leading candidates right now are Luxon and Temporal. And of course, the Temporal standard is coming soon and will hopefully by next year be the general standard, but Luxon's going to be here for quite a while, I imagine. So don't be afraid to use it. And in conclusion, that's me. Do check out mrdowden.com. That's how you can find out how to reach me. I would love to talk to you. If you've got some challenging projects where you're dealing with time zones, let's talk about it. I'd love to hear what you're working on. So thank you, and enjoy the conference.